everyone, I am Tulang. So for today's lesson, we are going to discuss the area and volume. So first, we will discuss about the area. So our objectives in this topic is to be able to learn on how to get the area of the curve. So first is the application of integration. And in areas. So we have two topics under the areas, which is the under the curve and between the curve. So we will start by solving the area under the curve. So let's illustrate the concept. So first is we will draw the graph, and this is your y-axis and this is your x-axis. So this is your curve, and we will label this as y is equals to f of x, and with the interval of a to b. This is your a and this is your b. So to determine the area under the curve from a to b and shade the area of concern. So this is the area of concern. We will start by looking the point and draw the vertical strip. So this is your point, and we will label it as x and y. And this is your vertical strip. So this is the origin. This is your origin, and from the origin going to the vertical strip is your x, and the thickness of your vertical strip is your dx. So from this point to going down, that is your y. Next is we will remove this vertical strip. So this is your vertical strip, and remember this is your y, this is your dx. And this is your differential area, or the dA. And just remember that the differential area is just length times width. Your length is y and your width is dx. So y multiplied by dx. Next is we will integrate the area. So this would be the area of integral y dx. So this is the solution under the curve. This is under the curve. So we will have an example. First is we will erase this part. So we have the example number 1. Number 1 is to find the area under the line of y is equals to 2x plus 2 from x is equal to 1 to x equals to 3. So first is we will draw graph. This is your y, this is your x, and have 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So to plot the line, we need to have a 2 point. So we have here x and y. So we have, if x is 0, so substitute 0, that your y is 2. So if x is 2, and we will substitute this, so 2 times 2 is 4 plus 2 is 6. So we have to plot this 0 and 2, then 2 and 6. So 0, x 0 and 2, and then 2 and 6. So we have we will connect this dot and then extend here and extend here. So we will label this as y is equals to 2x plus 2, and then we will plot the limit, which is x is equal to 1 to x to 3. So 1, this is 1 and 3. That is 3. So this is our area of concern. Next is we will point here and label it as x and y because we don't know what point is this. And then we will draw the horizon at we will draw the vertical strip here. And then this is your origin, and from this origin going to the vertical strip, that is your x, and the thickness of your vertical strip is your dx. Next is this is your y. This is your y. Next is you will remove this vertical strip. So we will draw it here. And then remember that this is your y and the thickness is your dx. Let's erase this first. And then this is the area of this vertical strip is our DA, or the differential area. So we remember that DA is the length times width. So we have y multiplied by dx. So we have a y dx. And with the limit of 1, 2, 3. Next is we will substitute. So we have the integral 1 to 3. Our y, let's substitute y, that is 2x plus 2. Then dx. So we have the integral of 1 to 3. Next is we will integrate this. So we have 2x squared over 2 plus 2x. With a limit of 1 to 3. So let's substitute this upper limit to our x. So we have 2 times 3 squared over 2 plus 2 times 3. So minus the lower limit, which is 2 over 2 plus 2 multiplied by 1, and our final answer is, so the upper limit is 9 plus 6 minus the lower limit 1 plus 2, that is equal to 16 square unit. So this is our final answer for our example number 1. So next is our example number 2. So this is the example number 2. Find the area under the line y is equals to 2x squared plus 3 from x is equals to 0 to x is equals to 4. So we have the solution. First, to plot the line, we have to get the 2 points. So we have x and y. So if x is 0, our y is 3. If x is 1, our y is 2 times 1 is 2. Square root of 1 is 1. 2 times 1 is 2 plus 3 is 4. So first is we draw the graph. This is the x-axis, this is y-axis, and then we'll point the 0 and 3. 0 and 3. Let's assume this is 3, and 1 and 4. This is 4. This is 1. So we have to connect these dots and extend the line. Then extend the line. So let's plot the limit. 1, 2, 3, 4. So we have to extend pa. So this is 4 from the origin to 4. So this is the area concerned, and we will point here and label it as x and y because we don't know what point is that. And next is we will draw the vertical strip. This is the vertical strip. And then from the origin to the vertical strip, that is your x. And the thickness of the vertical strip is dx. And then the height of the vertical strip is dy. Oh, before I forgot, this line, we will label this as y is equals to 2x squared plus 2. Plus 3. Next is we will remove this vertical strip. This is your y, this is your dx. And the area of the vertical strip is differential area is equals to y dx. And then if you integrate this, you have area of integral y dx. So let's erase this part so we can write it there. Before I forgot, the limit of this is 0 to 4. This is the 0 to 4. So we'll write it there, the solution. So we have to substitute y to 2x squared plus 3. So we have integral of 0 to 4, then 2x squared plus 3 dx. So we have to integrate this. So we have 2x cubed over 3 plus 3x with the limit of 0 to 4. Next is equals to 2/3. We will substitute the upper limit to our x and then minus the lower limit. So we have 2/3 4 raised to 3 plus 3 times 4 minus the lower limit, that is equal to 0, because when you substitute 0 to this x, that will be 0. So we will write it as 0 equals to 4 times 3 is 4 times 4, 16 times 4 is, so this is 2/3, so 4 raised to 3 is 64 times 2 is 128 over 3 plus the 12. So we have to divide this. So 128 divided by 3 is 42.6666, or we can write it as 42.67 plus 12 is equal to, A is equals to, so this is 54.67 square unit. So this is the final answer for our example number 2. So let's move on to the area between curves. So next is the area between curves. So we have the illustration. So this is your x-axis and this is your y-axis. So we will draw the first curve here. We will label this as f of x. And this curve is g of x. And then with an interval of a to b. This is a and this is b. So this is the area. And then the formula of this illustration is area is equals to integral of a to b f of x minus g of x dx. So to use this formula, the value of x is higher than g of x. So for example, number one is find the area between the curve of f of x is equal to x cubed plus 2 and g of x is equal to 2 minus x between interval of x is equal to 0 and x is equal to 2. So our formula is area integral of limit of a to b f of x minus g of x dx. So we will write our a is 0, our b is 2, and then our f of x is x cubed plus 2 and g of x is equal to 2 minus x. So we will draw the graph here. This is your x-axis and this is y-axis. And then we'll draw here the f of x is equal to 2x, x cubed plus 2 and g of x is 2 minus x. And then our limit is from 0 to 2. So let's assume that this is 2. So from the origin to 2. So this area is our concern. So let's solve the area. So we have here the area, the limit integral with the limit of a is 0 to b is 2, and then we will substitute f of x that is x cubed plus 2 minus wait, okay. So this is minus g of x, 2 minus x dx. So we have 2 simplify this as x cubed plus 2 minus 2 negative times negative is positive x dx. And then let's eliminate these two, so we will have x cubed plus 2 minus 2 is 0, so we will not write that up. So we have plus x dx. So we will integrate this. We have area is equals to x raised to 4 over 4 plus x squared over 2, a limit of 0 to 2. So we have to continue this here. So we will plot the value of upper limit minus the lower limit. So we have equal to 1/4 upper limit of 4 raised to 2. 2 raised to 4 plus 1/2 2 raised to 2, so minus 0 because the lower limit is 0. So area is equal to 16 over 4 plus 4 over 2. So this will become 4. 16 divided by 4 is 4 plus 4 divided by 2 is 2, and we will add this, so we have 6 square units. So next example. So we have example number 2. Find the area between the graph of f of x is equal to 4 minus x and g of x is equal to x squared plus 1 from x is equal to 3 to x is equal to 5. So our formula is area is equals to integral with the limit of a to b f of x minus g of x dx. So we'll draw we'll draw here the graph. This is your x axis and y axis, and then we will draw here the curve of f of x is equal to 4 minus x and the g of x that is x squared plus 1. So we have the limit of 3 to 5. So let's assume that this is 3 and this is 5. So this area, so this is the area. So let's solve. Integral of limit a is 3, 2b is 5, f of x is 4 minus x minus g of x, x squared plus 1 dx. Next is, we'll simplify. Integral 5, 4 minus x squared minus 1 dx. So we have to eliminate this or minus this. So we have to arrange negative x squared minus x plus 4 minus 1 is 3 dx. So let's integrate this. We will continue this here. So we will integrate. Area is equal to negative x squared plus 1 is cube 3 over 3 minus x squared over 2 plus 3x, the limit of 3 to 5. So we will minus the upper limit and lower limit. So we have negative 5 cube over 3 minus 5 squared over 2 plus 3, 5 minus negative 3 cube over 3 minus 3 squared over 2 plus 3 times 3. So we have the area is equals to 5 raised to 3 is 125 over 3 minus 25 over 2 plus 15 minus the lower limit, which is 27 over 3 minus 9 over 2 plus 9. So we have to erase this and continue the solvings. So let's continue. So we have 125 divided by 3 is 41.67 minus 25 divided by 3 is 12.5 plus 15 minus, that is 9 minus 4.5 plus 9. So this is 47.17 plus this is 4.5, so equal to 44. So area is equal to 48.67 square units. So this is the final answer for our example number 2. So let's move on to the next topic. The next topic is the polar areas. So let's have the principles and concept. So first is the Cartesian coordinate system. So in this part is the polar plane. So in Cartesian coordinate system, this is the graph of the Cartesian. This is the x-axis and this is the y-axis. So if we point here, that is our, and label this as y, x and y. So this is the point x and y. So we have in this area this line. So from the x-axis going to the point of x and y is our y distance from x-axis. Y distance from x-axis. And this part is the distance, the x distance from y-axis. And this distance from the origin to the point is the square root of x squared plus y squared, or this is we called our distance. So next is our polar plane. So if we plot the polar plane, it will look like this. So in polar plane, the radius is given. So take note that radius is given. Note radius is given. So in this graph, this is our 0 degrees, this is our 90 degrees, 180 degrees, and this is the 270 degrees. So let's assume that this is the given radius. So this is the radius 1, radius is equals to 1, and this is the radius is equals to 2. So this is the degrees. So this is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, this is 180, so this is 210 degrees, 240 degrees, this is 270 degrees, then this is 300 degrees, this is 330 degrees, and this is the point of 360 degrees. So the concept of polar area on how we take the area of horizontal or vertical strip. So if this is the graph, graph in polar area, and then this is your polar curve. If this is your polar curve, so that is the r is equals to f theta. So this is our 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So if you want to solve this area, so if you want to solve this area, so we have to make a line. So here is we will make a strip. So let's assume that this is our strip. So this is our r, this r, and this is r. That is our radius. And then from the x-axis going to this line is our theta 1. And then from the x-axis going to this second line is our theta 2. And then this strip is our d theta. So if we remove this strip, so if this is your strip, this is our strip, this is our d theta, and this is our r. So the area of the strip is the area is equals to 1/2 r squared d theta. So let's integrate this. So we have area is equals to the integral of theta 1, this is theta 1, and the upper limit is our theta 2, 1/2 r d theta. So this is the principal under polar equation. So let's have an example. So example, number 1. If r is equals to 2 cosine 3 theta, so we will find the area of the given radius. So if we plot this in a graph, it will look like a 3 petal. So it will look like this. Let's flip. It will look like this. So let's solve the area of the first petal. This is the area, and our radius is 2, so this is 1 and this is 2, and this is the x-axis, the y-axis. So let's start with our equation. So we have a is equals to the integral of alpha to beta, 1/2 r squared d theta. So we will find the angle. We gonna put a line here, so we will find the angle. Gonna put a line here, same as here. So to find the two angles correspond to line. So the key to find it is the 3 theta. So if we will choose the 90 degrees, so we have 90 degrees divided by 3 is equals to 30. So it turns that the first petal is bounded by pi, this is pi over 6, and this is pi over 6, or pi over 30. So we have angle area is equals to the integral of negative pi over 6 to pi over 6, 1/2 r squared d theta. So let's substitute our r. Our r is 2 cosine 3 theta. So we have negative pi over 6 to pi over 6, 1/2 2 cosine 3 theta d theta squared. So let's have the area is equals to, if we multiply this 2 times 2, that is 4, divided by 2 is 2. So we will take out the the 2. Integral negative pi over 6 cosine squared 3 theta d theta. So take note that the cosine squared theta is equals to 1/2 1 plus cosine 2 theta. So if we have cosine squared 3 theta, so that is equal to 1/2 1 plus cosine 6 theta. So take note that. So our area now is equals to 2 integral of negative pi over 6 to pi over 6 1/2. So remember that cosine squared 3 theta is 1 plus cosine 6 theta. 1 plus cosine 6 theta d theta. So we have equal to integral negative pi over 6 to pi over 6. So we will cancel out the 2 and 1/2. So we have 1 plus cosine 6 theta d theta. So let's integrate this. So let's integrate. We have theta. Integral of negative. Let's write it here again. 1 plus cosine 6 theta d theta. So let's integrate this. We have theta plus sine 6 theta divided by 6. The limit of negative pi over 6 to pi over 6. So let's substitute this the upper limit to our theta and the lower limit. So we have pi over 6 plus 0, because when you substitute this pi over 6, that will be equal to 0, minus negative pi over 6, again here is 0. So we have pi over 6 plus pi over 6 is equal to 2 pi over 6, or we'll divide this. We have pi over 3. So this is our area for our first petal. So if you want to know the area of these 3 petals, you can just multiply this to 3. So the area of the 3 petals is pi. And this is the area for 3 petals. And this is the area area of first petal. So our next topic is about the volumes. So we have the disk method. So let's say if we have a curve, this is y-axis and this is x-axis. So if this is your curve and the distance from the x-axis going to the curve is r, and then this is your a and b, and then you will draw here the disk, so we will rotate this, so it looks like a cylinder, and from the center going to side is the radius, and this is the height, and the cross section area is on the top is this, and the volume of the cylinder is area times height, and the volume of the cross section is pi r squared multiplied by h, or the height. So the value of the cross section is pi r squared h so we have the volume of integration of a to b, area of x dx, and the area is basically this pi r squared h, pi r squared. So we will substitute for the area. We have volume is equal to the integration of a to b. So our area is pi r squared multiplied by x dx. So this is the equation to find the volume using disk method. So next is we're going to have an example. So we have example number 1. So we have y is equals to x squared, wherein limit is x to 0 2x is equals to 4. So we have to plot. This is your x-axis and this is your y-axis. So we have this curve. This is y is equals to square root of x. And our limit is 0 to 4. So this is the 0. So let's assume this is 4. This area, this is the area. And then the distance from the x-axis and going to the curve is r. So we have r is equal to square root of x, and then v, volume of pi integration of a to b r squared x dx. So we have pi integration of our a is 0 and b is 4. So our r is square root of x dx. Next is copy pi integration of 0 to 4 x raised to 1 dx. So next is we have to integrate x raised to 1 plus 1 is 2 over 2. So we have pi with limit of 0 to 4. So next is we will substitute the value of the upper limit and the lower limit to our x. So we have pi 4 squared over 2 minus 0 over 2. So this is now 0 equals to 4 raised to 2 is 16. So we have pi 16 over 2, or pi 16 divided by 2 is 8, or we can write or 8 pi square unit. So this is the final answer for our example number 1. So we have next is the example number 2. So next is the shell method. Shell method. So let's illustrate the graph of shell method. Y-axis and x-axis. So if we have this curve, and then this is our A and this is our B, so we will draw here the vertical strip, and from this going to the x-axis is the height, And then the distance between the y-axis and the vertical strip is r. So we have volume of 2 pi integration of a to b r x hx dx. So we have example number 1. So let's erase this. We have example number 1. So y is equals to x minus x cubed. Y is equals to 0 from x equal to 0 to x equal to 1. So first we will find the intercept. So 0 is equal to, we will factor x cubed. So we have x 1 minus x squared equals to x plus 1 plus x 1 minus x. So 0 is equal to 0, negative 1, and 1. So we will graph that as y-axis, this is x-axis. So we have this curve, this is A, and this is B. Oh, 1, 0. So we will draw the vertical strip. So from the x-axis going to the curve that is the height, and the distance between y-axis going to the vertical. So if we have this curve, we'll draw here the vertical strip. So from the origin going to this vertical strip is our x, and the distance from the curve and the x-axis is the height, and the distance of y-axis to the vertical strip is r. And then this is y. So next is we will erase this to continue the solution. So we have our r is x and our h is y. So we'll substitute y to x minus x cubed. So we have the formula. Volume is equals to 2 pi integral of limit of 0 to 1 x minus x cubed dx. So we have 2 pi integration of 0 to 1 x squared minus x raised to 4 dx. So we will integrate this part. So we have x cubed over 3 minus x raised to 5 over 5, the limit of 0 to 1. And then multiply by 2 pi. Next is we will substitute the upper limit and the lower limit to x. So we have 1 multiplied by over 3 minus 1 raised to 5 over 5 minus 0, because the lower limit is 0. So if you substitute this, you will get a 0. So multiply by 2 pi. Next is we have 1/3 minus 1 over 5 times 2 pi. So we have 1/3 multiplied by 5 and 5 minus the 1 over 5 multiplied by 3 and 3 multiplied by 2 pi. So we have 5 over 15 minus 3 over 15, 2 pi, or equal to 5 minus 3 is 2 over 15, 2 pi, or the volume is equal to 4 pi over 15. So this is the final answer for this example using shell method. So our last topic is the washer method. And let's illustrate the principle. So this is the graph. This is the x-axis and the y-axis. So if this is the curve, this is the B and this is A, from A to B. And then this is the area. So we have to point here, point somewhere, and draw a vertical strip. So this is the vertical strip. Then the thickness of our vertical strip is dx. and from the origin to our vertical strip is our x. So we assume that this is the number. We have to make a line here that's the line, and then we label this point as x and y, and then here is the rotation, the area of rotation, the AOR. So this is the y, this is the b axis, b, and then at this point we will make a washer we will draw here, and from here so this area is y, and from here the b axis to x axis is the b. So if this oblong shape is removed, so we will move here, so we have this line here, and this is the axis of rotation, and then from the axis of rotation to the x, so this is the x axis, that is the b. So this area is b minus y. And then the thickness of this oblong shape is r dx. So the area of this is, the volume, differential volume is pi b squared dx minus pi b minus y squared dx. So let's integrate. We have the volume is equals to the integral from the limit of a to b pi b squared minus the b minus y squared dx. So let's have an example. So we have here the Example, so find the volume of the solid object generated by revolving about the x-axis. The area bounded by y squared is equals to 4x, y is equals to 4, and x is equal to 0. So, if we plot this in a graph, we have y-axis and the x-axis. So let's point here. Here. So ry is 4x, and that is the parabola that opens to the right. So this is the origin. So that is the parabola, opens to the right. And then ry is 4. So we have to make a line from in the number 4. So we have 1, 2, 3, 4. 2, 3, 4. So we have to make a line here. So we will label this as y squared is equals to 4x, and this line is y is equals to 4. So this is the inner radius, and then this is the outer radius. So we will point it here and make a vertical strip. So this is the dx, the thickness of a vertical strip, and this is the x, the distance from the y-axis to the vertical strip. So this point is, we'll find this point. So we will substitute this 4 into the y. So we have 4 raised to 2 is 16, divided by 4 is 4. So we have, this is the point 16, so that is 4 and 4. So, and our x is equal to 0. So let's have, what is the value of of x, if y is equals to 4? So let's have the differential volume is pi, the outer limit, outer radius, squared, minus the inner radius squared, multiplied by dx. So let's integrate. We have volume is equals to the limit of from 0 to 4. So we have 0, so we have the integral of the limit of 0 to 4 by the outer limit is our y squared, that is the 4x. sorry, our outer limit, outer radius is y is equals to 4. So 4 squared minus the inner radius, which is the y, which is the 4x. So we have to square this 4x squared multiply by dx. So let's simplify. We have volume is equals to, we'll take out the pi. We have pi limit of 0 to 4. So 4 raised to 2 is 16 minus 4x dx. So let's integrate this. Let's integrate. So we have pi 16x minus 2x squared with the limit of 0 to 4. So let's continue this solution here. So let's continue. We have volume is equals to pi. So let's substitute the upper limit and the lower limit to our x. So we have 16 times the upper limit, that is 4, minus 2 multiplied by 4 raised to 2 minus the lower limit, that is 0. So we have 16 times is 64. Oh, sorry, I forgot the pi. That is the 64, 64 minus 32. So that is 0. So we will minus this. We have volume is equals to 32 pi. So this is the volume of the y squared equals to 4x bounded by y is equals to 4 and the x is 0.